continuing, so we have now the value. So yung pi change in elevation, so I would like to reiterate. So same floor kasi tayo, so that's why the change in elevation is 0. Then your velocity, or this one, there is no change in diameter ng pipe, so single pipe siya, this one will be 0. So the pressure head loss, it will be ito na lang, pressure loss. So the specific weight times your HF, balo na din nakuha natin ng HF kanina. So that will be the value required para natin to get the value. So let's go to, so since we have this one already, so let's go to the since we have your T here, then another length of here, traveling here, so I'm going to put here P things, so that will be a T. I will add P things here, T. So we have here T. T branches. And the flow rate, it's already ilan, so it changes na so we have pumasok is 57.82, then lumabas sa branches is 45.43. So we can input here the flow rate, which is 45.83. Okay, so for the friction factor na ginamit dito, so we'll be referring on this one. Okay, so we have your minor loss. So usually yung HF natin is composed, yung value nito, so usually yung HF natin usually na value ng HF natin is composed of your minor loss and so that will be plus major loss. Okay, so minor loss, it will be yung mga fittings. Yan. Okay, so minor loss, it will be expressed as this equation, that will be KL velocity squared divided by 2G. So divided by 2 times the gravity. Then our major loss, so ito yan siya, ang kanyang Darcy-Weisbach equations for the length of pipes. Now for the value ng KL, so we can get it here sa table na ito. So mapapansin nyo, we have pipe inlet, then you have the value of KL, which is 0.8. For sharp edges, you have 0.5. Well rounded, so you have also bound value. So this is the water flowing, okay? So water flowing doon sa type. So usually this is parang katulad sa mga tangke, then water na pumapasok doon. Then for pipe exit, papunta rin ito sa tangke, we have your sharp edges also, then rounded also. Now for sudden expansion and contraction, so we have also here representation. So we have yung diameter ng tubo, and then enlarged diameter din ng tubo. So makita nyo, we have change in diameter from small diameter to a bigger diameter. Now, the sudden expansion, we have your KL. So, you have here the equation ng value nito, which is equal to 1 minus d squared over d squared. Okay? Then, also, for sudden contraction, you have this one also. So, it will be based on this chart. Okay. Then, we have gradual. So, mostly madalang ito gamitin, but ang mostly ginagamit, ito yung gradual expansion. Because ang pressure loss ng sudden expansion and sudden contraction are very mataas. So, as much as possible sa design, we try to eliminate using this one. And we are using yung gradual expansion palagi. Just only to smoothen the design, you also to lessen the friction na generate ng system. But I already experienced that may time kasi pag during installation na especially pag gipitan na yung kabit ng mga tubo, mga fittings, so hindi maiwasan na gumagamit kami ng ganito sa site na mag-install yung may gradual na tawag nila dito as we called it parang plug, reduction plug or reduction fittings, reduction nipple. So those were the terms, layman terms. Now for this one, we have also the value. Okay, so that is the ratio. You need to find the ratio of the diameter nung maliit, then yung malaking diameter, then in order to get the value here. Okay, so the value of your KL. Okay, then for you have also the degrees of opening. Okay, so how much yung degrees niyan? 30, 45, and 60. Okay. Then we have also for the bends and branches, so mga elbows, so 90 degrees elbow, and we have yung 90 degrees metered. So ito mostly yung ginagamit, and ito 90 metered were ginagamit din, but I already hindi ko siya ina-advise na mostly gamitin because it produce also a great pressure loss. So pag minsan kasi nagagawa na lang namin ito sa site if nagmamadali na, and also nahihirapan kami makakita ng fittings na ikakabit sa site. So especially kung nag-iisa na lang siya, then mag-order ka pa sa Manila, yun ang hassle at nagmamadali ka na tapusin yung project. So hindi ko siya ina-advise na ikabit, but much better ito ang kabit natin sa design. So we have also 90 degrees metered. So this one can be achieved as small size. Mostly ito sa mga bigger sizes pwedeng i-achieve, but not advisable na ikabit. And also we have 45 degrees threaded elbow. Okay, so then also 180 degrees return bend. So this one was in actual size, in actual installation of piping, hindi masyadong nagagamit. Mostly ito nagagamit sa mga copper pipes. So mga copper pipes, you have palagi kasi mga coil, so that's why you have your bend. So then we have also T-branch. Okay, so we have your planche type, so then threaded connection. So yun ang planche type connection na sinasabi niya dyan, and threaded connection. Then we have planche also, again, and threaded. Then union, so you have threaded union. Okay, so we have already value ng bulbs dito pala, no? So bulb fully open, you have 10. Angle bulb fully open, you have 5. And butterfly bulb, swing check bulb, gate bulb fully open, 1/4, you have also the have 1/4 close, 1/3, so yung type of opening siya, then you have the volume. So we forgot here, so dapat pala dinagdag na natin yung we have here gate bulb, diba? So we put here the gate bulb, kasama siya. So we have here the gate bulb. So gate bulb. So the same also flow 3.65. So we have 57.82. Then we have the Reynolds number, which is 165,499. You have turbulent flow. Then the size of 1 inches. Then we have 26.6, 0.00105, 6.54 on velocity. Length is blank. Change in elevation is also blank here. Then when water density is 9998.91, so we have 9,793. Then okay, so ito ang iwan natin. Okay, so let's add this one. So since kasama siya dito, if you're going to add sa system, so it should be yung ito, usually this will become HF total. Total na siya dapat in terms. Okay, so this is total. So because it is composed of minor loss and major loss, so we'll add na lang dito. So we can compute nung value. So since that is KL, B squared to 2G, so let's for the T, so that is 1 inches. Let's go to the T. So this one. So we have threaded. So ang paano ko nasabing threaded? So I will specify here. So mostly kasi in project, when we say threaded, so that will be threaded connection. So that is thread. Usually yung tubo, if you have the section of the pipe here, so yung dulo niyan dito, so you have here threaded connection. So I will show you a picture so para we can fully understand. So ito yung mga threaded, no. So we have your threaded pipes, threaded T. So we have a threaded plug, union. So ito yung union, sinasabi niya yan. Threaded union, yan. Then we have bushing reducer, this one, that's also threaded. And we have coupling reducer. We have your cup. Okay, so yan yung sinasabi na threaded. So mostly kasi in terms of size, so it ranges from lower sizes. So yung size ng tubo na yan, which is yung threaded, starting from 3, I'm not mistaken if that is started with 3 8 inches. So that will be going to pataas until meron mga 1/4 inches. We have mostly we have your 1/2, 1 in 1 inches, 1 in 1/2 inches, and then you have 2 inches and 2 in 1/2 inches. Then we have also 3 inches. So mostly kasi ito yung 3 inches are not tawag dito, are not already, may time kasi na you can use threaded and there is a time you can use plunge. Okay, so ang kahirapan lang kasi pag threaded yung 3 inches mo, especially pag mga kapal, napakahirap i-adjust yung so mostly this is welding. So nakikita, so for stand hindi na kayo malito, we'll try to remove the 3 inches na lang. So we're going to consider 3 inches as a flange connection ng mga pipes. So this is the range ng tubo na which is in threaded connection. So if you're going to plug in the mga size na yan, so you will be using mga fittings nyan mostly are threaded T, threaded elbow, threaded union. So yun yung ano, and also threaded din pati mga glow bulb and check bulbs yan. Okay, mga gate bulbs yan also threaded. Okay, so for flange connection, so this is the representation ng flange connection. Ito na yung tsura niya. Flange connection. So usually pag nagdudugtong ng mga tubo, we have this one. So mostly kasi ang kagandahan when you are in flange connection, na-experience ko, the advantage of using yung pipe-to-pipe connection ng flange mo dito, if this is your pipe, and dito ang dugtungan yan. So the one of the advantage of using a flange pipe connection is that when I was working, and na-experience ko is ease of maintenance, one of them, ease of maintenance. Especially pag yung mga tubo nyo are experiencing yung especially yung kinukumbay ng tubo is high pressure pipes, and also when you say high pressure pipe, so it means high pressure and high temperature. So pag high pressure and high temperature, so ang tubo is subjected to creep stress and also high pressure stress. So ang kagandahan pag flange connection siya is pag nag-burst siya, napudpod o nagkaroon ng pinhole, usually it will be burst ng pag ganon, then you have to just only remove yung flange in order to kabit mo ang buong system. So yun ang one of the advantage of using a flange connection. And also mostly ang nasisira, minsan there are times na you have to replace it, yung madali, yung parang palagi na lang nasisira na piping, so you have to replace it maybe for 1.5 year, every 1.5 year you have to replace it. So that's why they change it to a flange pipe connection already. Or sometimes in fire protection naman, mostly we use flange type connection sa piping, especially if the building is operation na, gawa na, then we try to avoid yung tawag dito, we try to avoid yung disturbance doon sa operation ng owner. So we do flange connection, so we weld the flange outside the building, and then pag clear na yung building, wala nang gumagamit, so papasok yung installer, then we can do piping rather than we can do piping by means of flange rather than you do piping na by means of welding. Kasi kung halimbawa magwe-welding ka pa doon sa loob ng building, which is hassle na, and also baka makasira ka pa ng mga other equipments and ang owner, so it will be charged sa'yo. So that's why we do flange connection na pag in terms na tapos na yung building na go-operate na. So yun ang mga naman sa fire protection. But in mga industrial process ng so mostly it is for ease of maintenance. Okay? And also yung mga fittings natin, yung mga gate bulbs, okay, I'll show you. So tulad na lang nito, we have your gate bulbs, okay. So mapapansin nyo, they are on flange connection. So mostly ang sizes ng gate ng mga gate bulbs that required a flange connections, so usually yung mga fittings that required sa flange connection, so that is starting from 3 inches. Okay, So 3 inches above, pataas yan. So they are all flange connection. So flange connection yan, flange connection in the fittings na ito siya mostly. In the fittings. Fittings like bulbs. Okay? So yan. Bulbs, bulbs, mga bulbs natin. So that is butterfly bulb. We'll show you a picture para we can grasp. Okay, so yeah, bulbs. So we have your Y strainer. This one is, I think, a pressure reducing. You have another butterfly bulb here. So you will notice this is our all flange connection. Okay, so this one also a butterfly bulbs. So this is OSY. Ito OSY type bulbs. Okay. So that is nagre-range yung so 3 inches pa above. So we start with 3 inches above. So mostly if there is no obstruction sa piping, we do weld connection, not palagi flange connection yung mga piping nandito. So mostly yung mga katulad ng mga T's, we have your T's, elbows, they are all in weld connection. So welding connection siya. Okay? So that you have idea how to use this one. Okay, so let's compute, no? So let's compute your T. So let's go, T, that is 1 inches. So it is categorized as a threaded. So you have your KL, which is 2.0. So KL is 2.0. So we have, so pansinin ninyo, so we have two types of T. Yung flow niya are in horizontal all along the flow of the main, and we have your branches here. So you're going to compare this one. So parang tayo is from branches. So from here going here. So we are not diretso, not along. So we have here going to branches. So we'll be using threaded KL, which is 2.0. So for your minor loss, for your T, so we can use that one as so we have your H additional na dito P1, pressure 1 additional natin doon 1 dash A, it will be KL times we have your so that will be B squared, velocity squared, over 2G. So that will be 2.0 times the velocity natin doon. How much is the velocity we have there? So velocity pipe, so what we have, okay, 6.54. So this will be 6.54 meter per second squared divided by 2 times 9.81 meter per second squared. So we have 4.36. So this is meter squared second squared divided by meter second squared. So take note, mapapansin nyo, there is hindi siya naka PSI ano to, we need Newton meter squared. So the pressure of the unit of the pressure or yung force over square area. So we need to multiply yung specific weight. So we have a specific weight, so which is 9,793, and this is specific weight Newton per square meter. So we need to, multiply the density. Yeah, we need to multiply the density. So if you're going to multiply the density, so ang unit ng density, so that will be kilogram. So meter squared. So this will be cancel out na ito. So may 1 na lang. Okay. Oh no, isa pala. Kilogram. So we will be multiplying pala. So if we're going to multiply density, which is 998.91, so that will be kilogram cubic meter. So multiply natin yan. So ano may makakancel out. So we need is kilogram. So this is kilogram meter, Newton, kilogram meter second squared. So we'll have this one. So mabawasan na natin to. We're going to remove this one and this one, so you have already Newton. Okay, then ito magsasama na, then this one kilogram. Oh wait. Okay, so reiterating yung unit, so we can multiply muna. So we arrive again to Newton per square meter. So we multiply Newton cubic meter, multiply meter squared, second squared yung una, we have this one, then divided by meter second squared. Okay, so we arrive in square meter pa rin, square meter. So we remove this one. So that will be, we're going to add here the specific weight in order to make it pressure. So specific weight. So we have specific weight which is equal to 9,799.3. So that will be 9,799.3. So this is Newton per cubic meter. So multiply by 2.0 multiply by 6.54 meter per second squared divided by 2 times 9.81 meter per second squared. Then we have the value of how much? It will be 42,724.95. That will be Newton per square meter. So here we have mas malaki pala siya. So you will see we have the value of dito, that is T is 2.0. So we have 42,724.95. So they have your Pascal. Now for that is your T. For the gate valve naman, so gate valve is considered as fully open. So we can gate valve fully open, we have KL, we have your 10. So makita nyo, we have also pole valve here, swing check valve, angle valve. So we use the gate valve, yung butterfly valve lang wala. So but we can use it, but here this one. So this gate valve fully open valves. This is globe valve pala, sorry. So globe valve, ano bang itsura ng globe valve? Ito will show you yung itsura ng globe valve. Okay, so ito yung globe valve, no? So you will see the difference ng OS, para siya ring OSY valve, but yung ang loss niya napakataas. So mapapansin yung multiplier niya doon. So global fully open, that is 10 yung multiplier niya, yung KL niya. So you will notice bakit ang laki. So makikita mo rin naman sa kanyang sectional view, which is yung flow niya, then paakit siya ng ganun. So ang lakas na ng obstructions of flow niya. Then ito yung seat niya, yun ang nagpipigil sa kanya in order for him to prevent the flow pump causing to the other side of the fittings. So mostly ito ang one of the advantage ng globe bulb, it is good sealant siya. Good sealer siya in terms. So makikita nyo yung mga gripo natin sa tubig, it is made of globe bulb. Okay? So, and also malakas yung pressure loss niya in terms. Usually, pag multiply mo din, napakalaki nun. So, ito yung itsura niya. And that is the disadvantage of using one. And the advantage is good sealing capacity. Katulad yung mga gripo natin sa bahay. So, mapapansin niya, if you're going to dissect that one, that is made of globe bulb. So, let's go to compute yung yung kulang natin doon na require, which is yung gate valve. So we go to gate valves. So this one, gate valve fully open, we have 0.2. So we're going to multiply that one 0.2. So let's try to erase this. Okay, so dito natin lagay sa ibabaw. We can tapusin na natin. Then we have your again specific weight for your this one P1. Let's say we have your specific weight multiplied by KL, then multiplied by velocity squared over 2G. Okay, so we have 9,799.3, so that will be Newton per cubic meter, multiplied by KL, which is 0.2, then multiplied by the velocity, so that will be 6.54 meter per second squared, divided by 2 times 9.81 meter per second squared. So we have the value. So we have a value of 4,272.5. So this is Newton per square meter. So 4,272 plug in. So we have friction factor of 0.2. So we have here 4,272.5.